Hi guys, welcome to my new video on Docker. So as part of this video, I'll walk you through end-to-end working with Docker. In my previous video, I have covered bits and pieces where you might have seen how to work with Docker volume or how to work with Docker file. But as part of this video, I'll cover end-to-end. So let's start. Agenda for this session will be like this. First, I'll introduce what exactly Docker is. Then I'll give a Docker bigger picture. Where does it fits inside another environment or inside a microservice environment? How exactly Docker fits, like uh, being a container, how we can manage in between a microservice architecture. Then I'll go Docker deep dive where I'll explain about different concepts of Docker. That will include Docker volumes, Docker networks, and other concepts related to it. Then I'll give a very high level overview of how exactly Docker and Kubernetes go together. And as part of Docker deep dive, I'll walk you through containers and image foundation, some cheat sheet on what are the top commands we have. Then working with images, what are the commands we have, like how to pull an existing image, Docker file, how to work with, Spring Boot application as a Docker image, and also the multi-stage build, where we can divide the responsibilities, Docker volumes, Docker networks, and Docker memory management. These things I'll be covering over the few slides. So my next slide, let's go to that. So Docker introduction. So this is already be covered in another videos as well, but I'll give still some details about it. What exactly Docker is? Docker is basically it's a platform where you can create, run, and manage your containers, and you can share it across. Like consider Java. Java is a platform where you can write a program, you can build your jar file, or you can build an application and share it across. Same like Docker is also a platform where you can create a containers. Like that, we have different platforms also where we can create Docker images or Docker or some different kind of containers. So these containers uh, actually are the runtime entities. So basically, what exactly containers is, as this definition says. So it is basically a executable unit. What exactly a executable unit is? It is a combination of your runtime application and the environment. So all your dependency and your code is packed together into a single unit. That is a container. Like you have a requirement of Java application, so you have your code and you are building it into a var or jar file. After that, when you want to run it, when you want to package it and deploy it into another environment like your dev environment, your QA staging environment, then what you need to do is you need to have an environment also ready for this particular jar file to run. Like you might need a environment variable setup, or you might need some certificates to be installed. All those goes into a single unit, and that unit is called as a container. So this complete combination is called as a container, and this is also isolated process. So when you run containers, containers are basically run into a single big machine. So many containers will be running together. So there should be a level of isolation between the different process, and that isolation is achieved by using CG group. So CG group and namespace are the concept that comes from Linux environment. So where when you create a new user, every time it creates a new group or user is attached to that group. Based on that, the complete resources sliced away from one user to another user. Like if you have a bigger hard drive, that hard drive will be shared between different users and namespace. So that concept is utilized inside containers also, and containers uses it for the isolation level. So as per the below diagram, so containers is a combination of your application plus your environment. But when you go with real-time example, there is a Java or JDK application, might be a Spring Boot application that might require Java JDK installation and some certificate installation, some property files should be there. So all those things you can club it together into a container, and that container can be he ported from one environment to another environment. So the very high level architecture of a Docker environment is like this. You can see a Docker daemon, which is the core of this Docker environment, which is the Docker server also. Then it exposes things over REST API and also the client also, Docker client also. That client utility deals with containers, images, all management is done by that one. Network management, data volume management, everything is done by using this REST API or client. Docker daemon manages all those things. This is a very high level diagram. I'll go into details where I'll give more in-depth details about all these components. So next thing, let's just do a very basic comparison between a virtual machine versus a container. So in the virtual machine or the hypervisor world, which is kind of before this containerization, every a application was built over this virtual machines. So what was the concept was we have a bigger hypervisor. Hypervisor is kind of a very big machine which will have a RAM of 100 plus gigs and uh, s- those RAMs will be sliced out into a multiple CPU or RAM, and that individual will work as a new machine, new complete new blank machine without an operating system. Then each machine has to have an operating system, other drivers, network interface, everything each machine should have. Then application will be deployed inside that particular virtual machine. So this was the kind of architecture we used to follow without a container. But in container world, the architecture is a bit different. We have again a bigger machine, but already a operating system is installed. And over that operating system, we have a Docker daemon is also installed, which does the slicing for us. And instead of creating a hardware kind of slicing, it is creating a software kind of slicing where you are given a new user over the same operating system. So these containers does not require a separate operating system, but already existing operating system properties or core it will use it for. And over that container, you can have your application running. So better than the virtual machine environment where you have an overhead of each machine as a separate component and again network interface and many things needs to be there. In the container world, you don't have to deal with those many lower level component and high level component are available with us. So this is kind of very high level comparison between virtual machine and container. Next thing is some more architecture design of Docker system. So here we have the core. The middle of this diagram is Docker host. Docker host is basically a machine where Docker daemon is installed, and that will include the management of containers, image, everything will be inside that Docker host machine. And this can be a single machine as well as a distributed machine as well, where you can have a cluster of machine and that will be treated as a Docker host. And then we have a client. This client is again a tool which can interact with the Docker host. This can be in the same Docker host machine or this can be a remote machine as well. And the feature what client is capable of is kind of client can build Docker images, pull Docker images, and run Docker images. These things client can do. And we have the third component, which is kind of registry. Like in Maven, we have in Git we have repositories, so where we push our code, and that code can be accessed by any other person who has the authority to access it. Like that, here also we have registry where we push our built images, and that images will be accessible over the uh, other guys who have the access to this repository. This can again be a private repository, or by default we have a Docker Hub registry that can be used for pushing your built images. And again, this is again a critical component. So uh, many architecture complexity will come in terms of registry also. Okay, so container bigger picture. If you go with the microservice architecture, where exactly container fits, this slide will give you detail about. So if you see the diagram here, this is kind of a microservice architecture. So in microservice architecture, the responsibility is divided into multiple services. Like we have different service which have their own specific set of responsibilities, and those responsibilities or interaction between them is done through either API gateway, discovery service, and internal communication between microservice. Everything is being managed. So client here comes and does authentication and authorization through API gateway, then it gets all these details of microservice. So here you can see so many components are there. There is a client is there, identity provider is there, API gateway is there, and we have n number of services we have, remote services we have. So each of these elements are in a virtual machine environment. We have to create a virtual machine, a separate VM for each of them. But in terms of Docker environment, you don't have to create a virtual machine, but instead of virtual machine, what you have to do is create a container of it and deploy in as many environment you want. So but we have a complexity level increased here. So in this case, when we have so many components, so many containers and all those, then we have a complexity of management of all these containers. And that is being managed by another service, which is kind of Docker Swarm or Kubernetes, which are kind of container management or orchestration tool, which are capable of handling these kind of responsibility, like when we have many containers, if some containers fails, what will happen, how it will handle, everything is already defined inside these kind of tools, which are Docker, Swarm, and Kubernetes. In my upcoming video, I'll include working with Kubernetes, how you can create containers and use inside a Kubernetes architecture. So this is a very high level understanding of like how exactly container fit inside a microservice architecture. If you have reactive microservice also, then also Kubernetes is good for that one. If you have SOA kind of architecture, then also Kubernetes is good in those environment as well. So let's go to our next slide. That is kind of Docker deep dive. We'll go into containers world and images. So very first thing here is image. What exactly image is? Image, as we discussed before, what is an image is basically it is kind of prototyping of your container, or it is kind of read-only layer of your container. So where if you compare with the Java world, this is kind of class where we define things, and then we have containers, which are kind of objects which are the runtime entity of those images. So images are basically a definition of whatever you have defined in the environment, or whatever feature you want. The complete definition will sit inside an image, and the executable or runtime entity of that one will be your container. So container images have a read-only layer attached to it. Everything is inside containers are read-only. Images are read-only. Images have everything on read-only. So containers make use of that read-only images, and then over that it attach a writable layer to it. So containers will have a writable layer also attached to it, where we'll have operation like consider you have a Java environment. When you want to pull some data and put it inside a folder, then those kind of write operation is done over the writable layer of the container. So read-only layer will not be modified, whatever there inside your definition will be kept like that, and over that writable layer will be there where new updates or modification will be done. So this concept is called copy on write, and container uses this for overriding the read-only layer and adding changes to your images. So from one image, you can create as many containers you want until the system is capable of taking that load. Okay, so after that, we'll go with some of the Docker command cheat sheet so that it will be helpful. And when I will explain about all these commands, you'll have a understanding of those. So basically, Docker command format is also of the type of like Linux command format, where if you see the format is of type Docker resource and options. So Docker is there, and then the resource will be either images resource, container is resource, volume is resource, network resource. These are the resource, and over that we will have an option to it, like ls list out all of the resource, or uh, get the details logs of those resource. Those things you can do over a resource. So this is the format, and also the chaining of that commands, like in Linux we can get the output of one command and push it into the input of another command. All those options are available with Docker as well. Then we have a list of utility commands also: Docker info, Docker dev, Docker events. So Docker info is kind of if you want info about any resource, like image. If you want get more details about an image, you can do a Docker info. Docker dev is kind of seeing the list of changes over that particular images. Like as I told, writable layer is attached to a Docker. So you can see that whatever changes are made in the writable layer by using a docker def command. Docker events is the global level events. You can see a list of popping out event. If you are creating an image or running an image, everything will be listed out inside a Docker events. Docker inspect is kind of you can get more details about what exactly that resource is uh, a resource has, what are the internal configuration, everything you can do by using Docker inspect. Docker logs is kind of if the Docker image is attached with a log, you can see that Docker logs. Docker port is there, like if the Docker images is having some open ports, you can see it from there. Docker stats is for the memory management. You can see the how much memory consumption is there in the live stats. Then we have images. Images have some commands like Docker images. It will list out all the available images in a machine. Docker images digest, which is good for getting the details about what is the unique digest MD5 code for that particular image. You can verify or authenticate the source of that particular image. Docker help is there where you can get more images related commands help. Then we have some more commands like Docker image ls. You can see again the list of images available in your Docker host machine. Docker pull name is kind of pulling a Docker image from your repository. You can pull an image by using name and then applying a tag. Tag is kind of versioning in Docker environment. You can see the in my another video also, like where I have explained more about the Docker command. Docker inspect is again inspecting about an image. Docker image push. If you want to push an image to your repository, you can use the Docker image push. Docker image build is kind of when you want to build a Docker image out of your Docker file, then you can run a Docker image build. It will take a Docker file from your local environment or from that current working directory and build an image. Docker image history, if you want to see that who are the owners and when the last patch was applied to a Docker image, you can apply a Docker history command and that will list out all those things. Docker RMI is kind of removing an image. You can remove by using a hexadecimal code. Then we have containers. Containers are runtime entity, so you can apply commands over those runtime entity if that exists in the environment. Docker container ls. You want to list out all the running containers, ls. Uh, so this gives only list of running container. If you want to see all the container that might be stopped or that might be in some other state also. So by using Docker container ls hyphen hyphen all, you can list out all of them. You have a filter also. You can apply that one, that filter by using hyphen hyphen filter, and you can apply a in double quotes you can apply your filter statement like exited is one of the filter statement. You can apply name wise filter, and then you can list out your whatever the running containers you have. Docker stop is if you want to stop a running container, this will stop that one. Docker rm is kind of removing a container, but you cannot remove a container until it is stopped. So a remove command only works when you have stopped it. Docker inspect, as I told, this is a utility command. You can see the list of details of that particular container. Docker logs is kind of seeing the logs. Docker ports, Docker diff, whatever changes apply. Docker commit is one of the very useful command. I like it. If you are trying to build a image at that time, Docker commit is very useful. When when you are running a container and that is kind of generating a new resources inside your running container, and at that point you think that that is the exact thing you want, that is the exact output of your image should be, or that should be your image. In that case you can commit that into a new container image, into a new image, and that will create whatever the state is there of that particular running container, that will be preserved in terms of a image, and that image you can use it for. Okay, so we'll start working with an image. For our very first example will be how to pull an existing image. So let's see how to pull an existing image from uh, your Docker Hub. So let's see how to pull an image. So here I'm into a Linux environment. I have everything in my system, like Docker is already installed, and I guess Docker is already logged in also. From the console or from the running environment, you have to log in with your Docker Hub credentials. Then only you will be able to pull or push the Docker images. So let's see what are the images I have in my local. So these many images are there in my local. You can see these many images are available in my local. So what command I used is docker images command. Images command I used. Let me create. And what are the containers which are running? I can see by using docker ps. So these three containers which are running. So let's try to pull a docker image from a repository. So what is the command we have is docker pull, and let's say and I will pull a alpine image. So alpine is basically a very light weight or version of a Linux image, uh, which will not have many features, but it is good for running a jar file or anything inside that one. So we just now we pulled that one, and you can see that the pull completed and download success. I got this one. And as I told, we have a command format of docker pull and name of the images. After that, we have a tagging version also. Tag is kind of versioning inside Docker world. So we can give a latest as the tag, which is by default. If we don't give anything, latest will be applied. So this command, by default, it pulled me a latest image from the Docker Hub repository, and this pull happened, and it is having a digest, and this is the unique ID of this particular image. Now I want to run this image, so let's see in the Docker images what is the ID I got for this particular image. So Alpine I got, and you can see that here is an image ID I have. So with the help of this image ID, I can run an instance of that container. So we'll try to run the instance of this container by using docker run. So first I'll try to run it and I'll show you that what is the problem with this one. So Docker run and I gave the image ID. So it is trying to run that one, and after that terminal came back. So what happened, whether the image executed or whether not, let's see that one by using docker ps command. So you see that there is nothing which is newly created. Whatever is there is already existed one. N- None of the containers are there which are newly created. So I use docker ps command for listing out whatever the running containers I have. So let's see what are the container which got created and also got deleted sometimes back. So by using docker ps hyphen hyphen all command, you can see that whatever the container is there, either it is exited or either it is up and running. So you can see that 47 seconds ago, there is a container which was started and which exited. So this is the container which we tried to run. So this is the container ID, this is the Alpine command. So why this happened is, let me clear it. So why this happened is we executed our container like this, Docker run and this one. So there is the entry point concept here in Docker. So what is the entry point is here? Uh, when this container is running, it needs to have some entry point or it needs to run something uh, which is kind of keep on executing, which is kind of keep on running so that this container is up and running. For that purpose, we'll give a command sleep for 1 day. This is kind of bash command which will say that keep this container running for a day. So after that, we'll see that one. So again, here one problem happened. What is the problem here is it started this container, but it is not leaving this terminal. So this terminal is tightly attached to whatever the output is there. So container is up and running, but still this container is not left. So let's open a new terminal. Let me open a new terminal and we'll see that whatever the newly containers are there. So you can see that just 34 seconds ago, this container is started and this is up and running by using this command docker run and the image ID and whatever the entry point command we gave. So this created a container and it is up and running. But this is not the right approach because the terminal is directly attached, and once we close that terminal, let's see what happened. Still that terminal is attached, it is keep on running, but we don't know what is the status of that one. So instead of that one, what we can do is we can run in a detached mode. So we can run that container in a detached mode. So let's see what is the image ID we used. So this is the image ID. So we'll run it into a detached mode where it will leave the current running terminal uh, after starting that container. So the command is docker run and the container ID, and the command is sleep for 1 day, and also I'll say that run it in a detached mode. So that will be -d. So you can see that now the terminal came back. It returned me the terminal, whatever I was working with, and also there is a hexadecimal code it returned back. So this is the container ID. This is the bigger container ID. There will be internal will be a smaller container ID just for displaying purpose. The internal will be there, but the actual will be this will be the container ID. Now we'll see the Docker PS. So just 29 seconds ago, this is the new container which is up and running. Let me clear it and we'll see what is the container. So this is the container. Now we have many commands with us. Let's try to run some of the commands over this container and see what happens. Now what I want is I want to see the details of this container. So I can say that docker inspect and the container ID, whatever the container ID is there. So inside the details of that container, you can see that there are many things which I have not explained yet. So you can see that ID is this one, created this one. So this is running a sleep for 1 day command, and also their status is up and running. All the details about that particular container is available with more into volumes, networks, everything is available inside this particular command. So this is JSON kind of output. And then I want to get into I want to get into that particular running container. So there is a command for Docker exec command is there. So by using that, we can run uh, some command which that particular container understands. In the interactive mode, exec I'm trying to run it, and what exactly I want to run it is shell prompt. So you can see that this is the way I executed a bash shell. So actually what I did is this is a running container. The base of this is a Linux image. So I tried to get inside this container, and I'm inside this container with the bash shell. And here if I do ls, I can see that what are the file system inside that one. So this is visible inside this. So by using exec, you can run some executable command which this guy understands, or which this container understand. So this way you can enter inside the running container. So this is the very first example uh, what we did was we pulled an Alpine image from a different Docker Hub repository. We don't know what is the repository, but by default, when you install the Docker, it will have the Docker Hub Global as the repository installed, and from there it pulled an image. As the image was not available in local, it pulled that image, Alpine image, and dumped it into local Docker host environment, and then we executed that particular Docker image and created container out of it. We created multiple container of the same image. We created one with which was attached to the terminal. Then we detached the terminal as to run it into the background. So this we did, and also we tried some exec command where we can execute some of the command which are understood by the that particular container. So that also we did. Now next thing is like let's go to the PPT and we'll see what is the next we have. So this we did using pre-built image, Alpine or Ubuntu. We just executed this one. Now next thing is creating your custom image or creating your own image. As we saw that we just pulled an existing image. Now when we create an image, somebody else can pull it from some other environment and they can use it. Like you have a Java application, you build it. Now somebody other want to pull that one, including your other dependencies also, like how exactly you run that Java application, or what is the main class, or what is the jar file name, everything. Other guy don't have to understand that one, just he can pull that particular image and it can be executed. So let's take an example. Uh, so let's take a Spring Boot example of that. So here if you see, so here I have a Spring Boot Docker example. So here, this is basically just a plain simple Spring Boot application, which is having just a REST services, nothing inside that one. So this is kind of Maven application. Maven inside, so it's just all the structure of the file system is same like a Maven application. And also I built the jar file. So with Maven clean and installed, I built the jar file. So this is the executable jar file. And inside that one, so in the same file folder structure, I have created a Docker file. So this is the Docker file I have. So this Docker file requires a from tag. From tag is kind of, so every Docker image should have a from tag or base image. Like this is a from tag is OpenJDK is the from tag. I'll give more details in the next slide, like what are the different components of this tag. So there is a file is required of the name Docker file. This is no camel casing. This is normal casing Docker file. So based on this Docker file, you can build your Docker image. Inside that, what it will be there is uh, you need to have a base image which will be inside a from tag. So I said I need a OpenJDK 8. Instead of this one, you can have a OpenJRE also. So there are already existing images are there which will by default will be pulled. So this image will be pulled inside your application, and then I have a maintainer tag which is kind of just uh, details about who is the maintainer of this one, metadata you can have it. And then what I'm saying is from the current working directory, from the target folder, copy everything inside the app folder. So the target folder will have the jar file, so that will be copied inside app folder. So this app folder will be inside the running container. So when you start the container, if it is a Alpine or Linux based image, so it will have a app folder. At the root, it will create a app folder, and inside that one, jar file will be available. The next tag is work directory. So this is a command like change directory. In Docker world, you have a working directory. When you do a working directory, that changes the directory where you are currently into. And after that, cmd is the command. Inside that, I am clubbing what exactly I want to run it. So like Java, jar, and it is kind of array of what are the executable commands you have. So this way we have defined this image structure. By using this, just you can build a custom image, very basic custom image. This is inside that you can have many different labels, many different layers also, and also multi-stage build. Many things can be inside this. So out of this, you are creating a very basic Java application which will be executable. Now, what you can do is from the working directory, like this directory, let me open a terminal here. And what I can do is I can build an image out of it by using the command docker build. I'll say that. So in this directory, I built an image, and the name of the image is I given like this with the help of tag. So this is the name of the image, or the this will be kind of like your Docker Hub repository name, and many metadata will be inside this one. So you can see that there is a kind of layered architecture inside this one. All this layer architecture it is built with. So first it built from whatever the from command we gave, it built that one, and it gave a hexadecimal code, and this is kind of sub layer. So first layer is built, over that next layer is built, over that again a next layer is built, copy of those files are done into next layer, then again next layer, and finally the final layer. So all this kind of layered architecture is built, and your image is built. So let's see that whether the image is built or not is listed out in the images or not. So if you see that one at the, so this is the image we built just now, Docker app. So this is the image we built just now, and this is available in your local machine. Now we'll try to run that one by using Docker. So this is the images available. We'll try to run that one and show how exactly we can run it. And also we have a Maven plugin also. By using that plugin, you can build the image as well, where you don't have the overhead of dealing with the Docker daemon. But that is good in the dev environment, but it is not in terms of real-time project environment. It is not that good, I feel like. Uh, Creating custom images. If you are trying to create a custom image, Docker file, as we did just now, from tag is kind of base image, and also we can have multiple from, so also like multi-stage build. So from tag is the base of any Docker file. Then we have maintainer tag inside that one. We have run command. It's kind of if you want some uh, image build, some layer you want, like preparation phase. If you're preparing an image, you want some preparation phase to be done, then this run command, inside run command, you list out all those things. Copy and add things are there. Just now we saw an example where we copied the build jar file from the local target folder into the app folder. And also we have alternative add also. If you have a requirement of like pulling some files from somewhere else or some other environment and dumping it into uh, your image with HTTP or some other protocols, then you can have the add commands inside that one. Then we have some more tags also, like working directory is kind of changing the directory where you are working inside the current working image. Then we have expose. Expose is kind of when you are working with a container, containers are working inside an isolation or sandbox mode. So when you want to expose some services, like if you are running a Java application, you want to expose some port or something, then by using expose command tag, you can define that which port you want to expose it with. Volume is again, I'll explain in details in later section, but here also you can define inside a Docker file what exactly volume is, which volume you want to have it. And also we have CMD or entry point. CMD is basically uh, is kind of the executable command which will keep on running for running that container or making the container live for your requirement. An entry point is there, which is an alternative for CMD. I'll come up with some example and explain more. Comments is like number sign is there. You can add comment inside a Docker file. So just now we saw that creating basic Alpine image with sleep command. Uh, we'll see some more example on copy, add, and CMD entry point with example. Spring Boot, we can create an Spring Boot application. Just now we created a Spring Boot application with expose, and with hyphen P option, you can give a port details like from this port to that port I want to tag it with. Multi-stage build also will see what is multi-stage build is like kind of dividing the responsibility. We have consider the case of a Java application. Just now we saw an example. What we did was we did a copy of the already existing jar file from the target folder into the image. So we just copied it. But instead of, if you have a requirement where you have to build that image, then what you can do is you can use one from tag and there you will build it. And in another from tag, you can copy that jar file, whatever the jar file build, into that another from tag. And based on that, it will create an image of that. What is the benefit of doing like that is we are dividing the responsibility. So build responsibility is given to first set of from tag and then it got built, and second from tag is kind of only building the image, and final image will not include, like in the first from tag you have to copy all your source code and Java dependency, everything needs to be there in the first from tag. Then only it will be able to build your application. And once the jar file is built, which is the application here, then only you can copy that jar file into another environment. So copying of all jar building in with source, that responsibility we have separated out. In that way, when the final image is there, which is only with the jar file, it will be a very lightweight version instead of having all Java dependency and your source code. The final thing will have only the jar file, which is kind of an executable there. So we have very important concept which is called volumes. Volumes, the purpose of volumes is uh, what happens is, as we discussed sometime before, like images have a read-only layer, or the containers have read-only layer plus writable layer attached to it. So whatever we do in the container, or whatever in the changes we do inside a container, that is done inside the writable layer only. So, but we have a problem with that is everything, whatever we do inside the writable layer, the life or the scope of that file is only limited to that container. So the life, I'll give more example on that. We'll explain it more. So we have different types of volumes also, like local or external. In terms of local, the Docker host machine will have the file system. That file system you can use it as a volume. External, like SSH based. If you want your file system to be SSH based, you can use SSH based file system, S3, NFS based file system. There are many plugins are available with the volumes. You can plug and play directly, as the volumes are also kind of one container. You can pull it, the image of those, and run it. And also we have examples also, like local SSH based mountings. Containers. So basically containers is kind of layered architecture. Just now we saw when we built an image Java application, what happened was it first built the from base image, like when we use JDK as the base image, it pulled that image, and then over that it applied multiple layers. First it installed this, then installed that, and after that finally the Java application it added. So everything is kind of layered kind of architecture, and the final layer is kind of writable layer, which is for the container. When the container is running, it will have that writable layer. So that writable layer, the Java application or this container will work with. But this is in case of like when we have a persistent based container or MongoDB or MySQL or any database, it is bit difficult to say that everything should be in the writable layer, which is tightly coupled with the volumes and it is not exposed outside. So only if we have this kind of requirement where we have to go with containerization of MongoDB or MySQL, this writable layer attached directly and writing it the data into those layer is not a good way. So what are the problems without volume we have is like writable layer or container. So these two are tightly coupled together. They have the same life cycle. Uh, both live together, both die together. So once container dies, this writable layer also die. So if it is a virtual machine, if it dies, it stopped because of some reason or because of some problem, we are not able to access it, and we have to remove that particular container, then everything written inside that one is lost. That is a big problem with that. So for dealing with that, we have another concept which is kind of volumes. Also, we have a problem with if some other container want to access this data, like in distributed kind of database storage architecture. If you want to have this all this data whatever written in the writable layer to be accessible by another container also, this is difficult to access that. So that is not possible in terms of writable layer attached to it. So these are the problem. But with volumes, what is with volumes we have the benefit is like host machine, which is kind of where the Docker daemon is running. In that system we have a file system. This is the file system we have. So with the help of Docker volumes, we can attach this Docker volume, uh, the file system. so that the Docker containers can start using this file system with the help of Docker volumes drivers. And whatever writable data is there, it can be written to the host machine, as well as if some people will have doubt if the host machine, which is a big cluster machine where the Docker will be running, if that also goes down, what is the alternative? In that case, we have SSH based or remote file system based drivers also, or S3 file system also, where you can store this data. So by using this file system or Docker volume, you can write data into the Docker host machine, and you can start interacting with the file system. And whatever you write, that get persisted into the Docker host machine. So this is the benefit of Docker volume. So we have even different types of volume, which is for different kind of requirement. You can go with different types of volume. Like bind mount is there, which is the default type of volumes in containers. So here what it does, it's tightly couples your file system with a Docker area, within your Docker area only. Docker area is, if you type a Docker info command, you will see that there is a Docker area attached to your Docker daemon, which is kind of one common folder structure, or like the var lib docker, where when you create any volume, every data will be written inside that with a new folder. Like if you want a new volume with the name ABC, that will create a new volume folder inside that var lib docker data volume and ABC. So whatever the data you write there, it will be persisted inside that folder only. So with bind mount, you have a limitation of only a secured area, only a Docker area you can write data to. And we have second type is kind of volume, uh, where what you can do is you can write data to anywhere in the file system, anywhere in the file system, saying that uh, in the host machine you can write data anywhere in the file system, anywhere. uh, you can write, like you have some already pre-populated data, then you can write use that data also. You can map that with the bind mount, and that will be used as a your data volume thing. Then you have tempfs mount also, which is kind of uh, one good concept when you want the performance optimization, uh, to reduce the problem with writing it into outside some file system, or writing it into the current writable layer. Instead of that, you want only runtime in memory data writes, then you can go with temp mounts. The data which you don't want for a long-term use case, like you want only till the Docker container is running. In that case, you can go with the temp fs mount file mount systems. So for working with volumes, you have many commands also attached to it. Docker volume create hyphen name. With name, you can give a name to a Docker volume, and that uh, by default it will be with a bridge type of driver. Bridge type of driver is by default for a single host machine, which bridge driver is used. So we have different volumes drivers also, that also I'll explain about. So second is like you can give the driver hyphen D. With that you can give the driver option also. Docker volume ls, you can list out the volume details. You can inspect the volume by using inspect command. rm volume is like you can remove that volume attached to it, but make sure you are not deleting some important data or some already existing database populated data. So doing this one is bit a risky job. So do it in your local environment, but don't try it in some production environment. Docker hyphen v is also like at the time of running a container also, you can give directly hyphen v option, saying that this is the container volume details, where you can have the volume name, whatever volume you have created in the previous section, that name you can provide it here. Then container mount point is the target location where when you run the container, where exactly which folder you want to map with the this volume folder. So whatever this volume folder will be directly mapped with this location. And also you have an option of giving it read only or read write access by using RO or RW. Oh, you can provide that one and then run an image ID. You can use this command for running a container with a volume and that volume is mounted to this particular location. And also you have an option of running a hyphen hyphen mount uh, way also. In this way, you have the option of giving the type of like what type of mount you want. As we discussed, three type of volume we have. Type equals to bind is bind mount point, and source equals to where exactly you want to map that bind mount point or the folder inside this particular volume, which folder you want to map it to. So this things you can give, and also here also you have the read only permission. You can play with read and read only and read write both permissions. So for the last option, which is tempfs, temp file system, what you can do is you can run it like this: hyphen hyphen mount type equals to tempfs and destination, because this does not have a permanent storage location. This is in memory, so you can give only the destination, but there is no target is involved. So this way you can play with volumes. Some more reference I have listed out. If you want, you can go through this, like SSH based file system, how you can attach S3 based driver. So all these examples are listed out, and also there is a training play with Docker example where you can directly play with the live example playing with Docker volume SSH file systems also. So next is Docker networks. What is Docker network and why do we need it? All these things we'll talk here. So let's start. So network, what is the requirement of network here is, and what is CNM container network model design? So basically, this image is I have taken it from some Docker definition. So in this image, you can see that every container network is inside a sandbox modes. And so container cannot directly talk to outside world as it is running inside a sandbox mode. For that purpose, we have to expose an uh, endpoint saying that this is the port and this is the mapping for that one. And based on that, it can interact by using that endpoint. And that endpoint and the container details will be registered in a network. So like that, if second container also is registered into the same network, then these two guys can talk to each other by using their name or by using their IP address. So there is internal DNS is already available inside each container environment. A very lightweight DNS identification system where it by name also it can discover other systems. Other system it is if it is there in the same network. So what is this base architecture design principle says is every container is running inside a sandbox mode, but if it wants to talk to another container or another service, then it has to register itself into a network where another guy is also registered. Like these two guys can talk. These two guys can talk. So um, one container also can be registered into multiple network also if it is having the responsibility of talking to multiple different types of containers also. So this is the basic design architecture. So we have even different types of networks also. If you want to work with a single host machine where you don't have a requirement of like uh, your cluster is only of a single big hypervisor machine and everything is sitting inside your same Docker host machine, you don't have a cluster enabled or Docker Swarm enabled, in that case, you can go with a bridge kind of driver. Bridge kind of driver is capable of only dealing things inside a single host machine. If you want to go with a Docker Swarm or which is a multi-cluster or multi multi-host architecture where you can have master slave kind of architecture where master is your host machine and another slave machine are also capable of building images for you or dealing with the client. In that case, you have if you have a container which is sitting inside one container host and another container which is sitting inside container uh, another host machine. In that case, if those two containers want to talk to each other, want to interact in some way or another way, then in that case you have to go with a driver called an overlay kind of driver, which is capable of dealing with multiple cluster-wise network. And if you have some more complex architecture where you want multiple cluster or one Docker kind of cluster, want to deal with a cluster which is not a container-based architecture or a VM-based architecture, then in that case you can go with MacVLN and IPVLN. You can go into more details of those, and based on that, they can communicate with each other. So as I told, bridge network is capable of handling within a single host machine. Overlay driver is with multiple hosts when the swarm mode is enabled. MacVLN is kind of communication from outside the cluster. IPVLN is also same. So this is one of the use case where you have Jenkins you want to build your Maven application, and from Jenkins you want to push it into a Docker daemon. So this example I'll talk in my next upcoming video where you have a requirement like your Java code is there which has to be Dockerized, and Jenkins will pull your code from Git repository, then build your Docker image based out of your Docker file definition. Then it adds all your required environment details. Then that built image, it will push into a Docker Hub repository by using a pipeline, Jenkins pipeline code or Groovy script. And from there, uh, even next Jenkins job can pull this Docker images and deploy it into your cluster, which can be a Kubernetes-based cluster or Docker SAM-based cluster. So this example, a use case, I'll be covering in my very next session. Thank you guys. Thank you for watching this video.